Hello everyone, my name is Roger Karube from Selldorf Architects, and I'm with Anne Lewison and Joe Kinas. Also from Socotec, we have Alex Barmas with us. Unfortunately, Kim Oswald couldn't make it, but she's also a very important team member. And just with other teams, thank you very much, Boston Valley, John, Andrew, Andy, of course, and Connie, Mellon, Omar, and University of Buffalo. Thank you for this wonderful opportunity. We were really honored and had a wonderful time experiencing this. It was a great learning curve for us, even though we do have more experience than other teams probably with terracotta, but we still learned a lot, and so thank you very much for that. So first thing we did actually, we reflected on our past projects that we worked together with Boston Valley, thinking what we would do differently if we were to revisit these projects. This is, I believe it's the first collaboration with Boston Valley back in 2009. It's 520 West 19th Street in Chelsea, in New York. We were interested in this intricate profile of the terracotta with how it interacts with the light and movement. Quickly followed by this, maybe it's actually on one of the Boston Valley brochures. It's 200 West 11th Avenue. We get more bold with the panel size and as well as the metallic glazing. The facade is facing the Hudson River, so we were focusing on how the surface interacts with the sunset over the Hudson. I think it came out as we wanted. And here, I hope you've seen this at Boston Valley, the mock-up. We're very happy with the result. This is, I think, one of the latest, or if not the latest project we did with Boston Valley here, completed in 2019, right before the COVID, in this project in DC, that we kind of moved away from the bold profile expression, and rather this is more about the colors, and I think we all know that longevity of the color, and for this kind of building, the colorfulness as being concept, it was important that these colors won't fade, as well as this imperfections of ceramics that brings more variety and subtleness to the facade. That's something that we were very happy with the result. One thing that came up over and over again is, I think John Krause, in your earlier presentation earlier in the week, already pointed out, it's really the weight, especially when you try to do something bold form. As he mentioned over here, we do have structural steel supporting it, in turn supported by upturned beam, and that also gets supported by all the way down to the foundation, each adding more materials, more weight, especially these are high embodied carbon. So this is something that we were starting to think, well, maybe this is something, the theme that we could tackle. And Alex, maybe, yeah.
Hi, I'm Alex Barmas with Socotec. So my first interaction with Boston Valley was with the project at 1 Vanderbilt. And I think picking up with what Ryoji was discussing, one of the main aspects that drives our clients, architects, to terracotta is texture, depth, expression, the expressiveness of the material. But it also comes with these limits. So with 1 Vanderbilt, we used a very standard extruded baguette. We worked a lot with Boston Valley on getting the texture into the glaze by kind of varying the glaze and the pooling of the glaze. But really it's a baguette, metal supports, curtain wall. So, to get this diagonal expression that KPF wanted, it's really about using metal to make the expression. There we go. Similar, not a Boston Valley project, sorry. The other alternative with this is to get depth, sort of a similar amount of depth on this project. You wind up, I can't leave here. You wind up, double facing the terracotta, introducing a lot of ribs into the terracotta, gluing bits of terracotta together to start generating that depth of profile. I think, this interaction with Selldorf here was about finding kind of a different way to approach this.
There's one more.
Oh, is there one more? Yeah, so I guess looking at it from the construction point of view, you can see the terracotta baguette that's been cut on a bias, but it's got a lot of aluminum track. Same idea, you still have a lot of metal support, but also you have a lot of two faces of terracotta. You have all of the ribbing to get really roughly the same amount of depth. We're talking that amount of depth with that amount of gubbins to make it work.
For the DC project with the colors, I had the opportunity to visit Boston Valley to inspect the first batch of tiles. I had the opportunity to also visit Guarantee Building, this experience really stuck with me. This ornamental quality of the terracotta from Louis Sullivan's days. There's something that you don't really need to be an architect to appreciate this, beauty, ornamental beauty. And there's something that kind of led us to think about, can we combine that ornamental quality, which kind of contemporary architect we shy away from, but maybe we can do something. And we're thinking maybe if that ornamental texture pattern had structural property, that geometry actually helps us take advantage of the compression strength of the terracotta, and therefore able to reduce the weight of the terracotta and be able to use it with the current rainscreen system, because there's a lot of advantages about the rainscreen system that you can have. I'm sure you all know about continuous insulation, and you can breathe, you can replace, so it's even at the end of the life cycle, you can recycle or give it to other building for adaptive reuse. So we wanted to challenge. That's how we came up with our challenge. We wanted to minimize the weight, but maximizing the style and also the recycled content. And we set ourselves our goal to reduce the weight by 50%, and by doing so, we can reduce. It's kind of the knock-on effect of the heavy weight we're reversing. So there's a knock-on domino effect of, we can reduce the subframing, we can reduce the overall building weight, we can reduce the thermal bridging. By maximizing the size, you have less clips, less subframing. All ends up in reduced material use and raw material extraction, not just for terracotta, but for other materials behind it as well. And also the ease of transportation and installation. Our goal was that one person can install it, two person can easily install these. And I think I already mentioned about the repairable, replace and recycle ability. And lastly, we wanted to try, with a lot of help from Andy, to use the post-consumer recycled content. We know that Boston Valley already have a lot of pre-consumer recycled content, so those were the things. And this is the parameters that we were given by Boston Valley, that minimum thickness possible is 3/8 of an inch. We were going after, because of the ornamental quality and the strength, we were going after ram pressed tiles, and that maximum is 30 by 24 by 12. And this third one is pretty important. The kiln to fire most efficiently in Boston Valley kiln, you have to keep your thickness to 2 3/8 inches. That way you can utilize all the shelf and fire as many tiles as you can in one go. And that because firing is where a lot of the energy is coming from in the production process. So that's why we set up our goals. Here's our initial study about, immediately when you think about structural geometry, we think about catenary curves of Gaudi's, or, this one we were looking at sine wave, and we tested out how it would look at 2 feet long of convex and concave, or reduce it down to 1 foot, eventually to 8 feet. So more ups and downs, of course, more materials, but also it has an impact on aesthetics as well. So we were looking at it both at once. And this is a little bit of development where we start settling in on 8 by 10 module. Here you can see how it looks in. So when you combine those modules, 3 or 4 together, it becomes 24 by 30 or 40. And that could become one single tile. Here, the one thing that we weren't happy about that froze. We weren't happy about is that this continuous wave, if you will, made everything blurry. It didn't have the edge or that could interact or could express the depth of the tile, nor the way interacts with the light and shadow. So something we went back and started tweaking. Up on the top is the same concave convex wave. We reduced the convex and increased the concave to exaggerate the depth. And finally, we just got rid of the concave and became just a big series of big bowls. And that's kind of the process. What's interesting is on the X, in one direction, you still have this little bit of concave and convex and concave, larger concave, but on the other direction, it's a series of bowls, and it creates the ridges. That's actually is the wave pattern. So we were happy with this, expressing what used to be a sectional cut wave pattern that is now translated onto the tile surface. Here we go. So this is what we ended up with. So we chop off the ridge to save some thickness, to maximize the size of each. We are calling it canoe, so that we can express the size of this geometry more. And also, once the tile is fit, you cannot really see that these tiles are only 3/8 of an inch thick. So we wanted to give a little hint that these ridges, we cut it to 3/8 of an inch, and that's how we ended up with this geometry. And Alex?
Yeah. So I'll talk a little bit about the structural analysis we did with Ryoji, with the Selldorf team, and with Andy while we were developing the aesthetics. But cutting to the ending, this is a very strange coincidence where the aesthetically pleasing pattern developed by Selldorf actually works fantastically well structurally. So, we started with what would be the stress patterning and peak stress in a flat 3/8 of an inch tile, and the numbers don't matter too much, but fundamentally what happens is when you start patterning the tile, when you start introducing depth into the tile, you pretty quickly drop about 40% of the peak stress under wind loading. So it's great. So this starts kind of helping us to accommodate the much larger spans with a relatively good factor of safety. As we went through the design exploration with the aesthetic patterning with Selldorf, am I also trapped? There we go. We looked at that. We looked at what would happen if you take the orthogonal tile and tweak the sine wave pattern by 45 degrees, and that actually helps a little bit more. But really, it's when you start creating these folds within the geometry, we're able to get a significant improvement in the rigidity of that tile. So it's kismet a little bit. The form that works best actually structurally was able to get us to below 50% of the stress under the flat tile. And so the idea here is fantastic. We're still using throughout the 3/8 inch wall thickness. It's now a single wall tile. It's not double wall. It doesn't require any ribs in the flat tile. And just by working the pattern, we were able to save a lot of stress.
Maybe it's a little bit hard to see, but you can see that each form is a lot larger by, abandoning a set of curves, concave, convex curve. So that's what we were happy with how we. So we move on to thinking about the actual building applications. We study how we turn the corners, we miter, but because of the pattern, we actually wanted the curve, although we weren't sure how that was going to be produced. It turns out mitering required a lot more work, a lot more hand work, because it's so delicate form and the thinness. You have to miter cut, and then you have to hand polish the thing, so there's a lot of danger of deformations and what have you. So we were happily proceeded to go with a curved corner, as you can see in the mock-up. We also had to strengthen a little bit of the bottom. This is actually for drying process. So when it's in a raw state, we need to prevent them from sagging. We did some corner curve studies, and we also initially we had these ribs merging into each other. We separated. We actually separated further, another 3/8 of an inch. At this point, we were really obsessed with 3/8. And that became the actual gap size between the tiles as well, so that this pattern will continue throughout multiple tiles. Here's the corner. We also we wanted to keep the minimum thickness for the corner tiles, but for the same reason, for the drying process, we had to thicken so that it has the surface to rest on. But these are not, again, this is diagonally following the ridge pattern, so it's not the full, but those were the adjustment we learned. And here is our final mock-up design. And there's a reason why the color is red brownish that maybe you can.
So in developing the glaze, we wanted to continue our sustainability strategy to see what materials we could incorporate into the glaze that might continue to investigate this story. And Andy was unbelievably resourceful in finding us a company that extracts heavy metals from iron ore mining and harvests them for reuse. A company called Enviroxide that had a collection of iron ore slag that we could use in our glaze. We did a little bit of work on understanding if we could use it both in the glaze and in the clay body. Just thinking what's next here. These are some of our samples where we were looking at incorporating the iron oxide in the clay body at certain percentages and in the glaze. Some of it was on a bone body and some on a red clay body. So we looked at a variety of these, but also were considering how we were going to make this mock-up and what would be our best backup for the mock-up, which wound up being a red clay body. But what you can see in these mock-ups is understanding the thickness of the glaze and how it was going to crest over the corners and the ridges and break over those, so we had some transparency in the glaze. So these we did mix in some of these little trials. Andy mixed the iron ore into the clay body, which we apparently could use if we'd like to. He said up to about 16% in the clay body as well as in the glaze. And these are the mock-ups that we got in the office where we could study how these things were going to work. And I'm going to give it back to Ryoji for the form.
Just one thing to clarify, this pigment is from environmental contamination cleanup from the abandoned coal mine. So we're cleaning, and I think the mine is in Pennsylvania, if I'm correct. So we're cleaning up our local environment and using the residue to turn it into something that's beautiful. So we're really happy about. Oh. So here's our mock-up. The one on the right is under the daylight, direct light. On the left, in overcast. We're happy with how the color changes and interacts with the lights. One thing that we didn't expect was this eye in the middle. This was not intended, as you can see on this corner tile. Center corner tile has an eye, but the two offset ones don't. And this is because the glaze actually pulled at the bottom of the bowl, the canoe. It actually pulled so much that it's more than about 1/8 of an inch. So this was a little surprise for us. Here's some more. We purposely cut the edges so that you can see the profile. So this is the final result. We're actually about 55%, rounded up to 60%, reduction in from standard 40 mil equivalent size Terra compared to even 30 mil version, which only can do 16 inches high. You're still about 64% of the weight, so we're very happy with the result. And the glazing, we mixed in this environment oxide pigment, about 14%, and the body. For the mock-up, we didn't get to use it. We just used their Boston Valley standard red, but we think we can add maybe up to, I think that we tested about 8% of mixing into the body, so I think that's something that we were very happy about. And I want to end with, we were really thinking about using this tile for our real project, and this is one of the renderings. You can see that we rotated 90 degrees for this. So thank you very much.